Welcome to Next Gen Cloud Computing. Master Linux and Cloud Skill for free.
Welcome back to part 2 of the Python for Linux admin series. Today we'll dive deeper into Python's subprocess module and explore some essential Linux commands that every admin should know. Here's what we'll be covering in this session. Display disk usage, show running processes, display CPU information, check available memory, show system information, and show uptime. If you haven't already, I recommend going through the first video in this series. It lays the foundation for using Python to execute Linux commands. You can also practice these commands in Google Colab, link provided in the description below. Let's get started with part 2 and take your Python and Linux skills to the next level. Feel free to follow along or choose specific commands to practice as we explain each one in detail. Let's begin. Let's dive into an essential Linux command. df-h. This command is your go-to for checking disk usage across all mounted file systems. It's like having a storage health check at your fingertips. When you run df-h, you'll see a clear breakdown of your disk space. It shows the file system name, total size, used and available space, and the percentage of disk space that's already in use. This information is crucial for any Linux admin to prevent running out of storage. And for those who love Python, we've got a script ready for you in Google Colab that uses the subprocess module to run this command seamlessly. Get ready to monitor your disk usage like a pro.
Next, we'll learn how to display running processes on a Linux system. This is important for monitoring system activity and understanding which processes are consuming resources. The Linux command we're using here is ps-aux. This lists all running processes on the system in a detailed format. PS displays information about active processes. A includes processes from all users. U shows user-oriented details, such as owner and CPU memory usage. X lists processes without a terminal. The output includes details like process ID, PID, CPU and memory usage, user who owns the process, and command or program being executed. Head over to the Google Colab link in the description to try this out. The Python script below uses the subprocess module to execute the ps-aux command. Run this script, and you'll see a list of all running processes displayed directly in Colab.
Now, let's learn how to display detailed information about your system's CPU. This is especially useful for understanding the capabilities of your hardware. The Linux command we're using is lscpu. It provides detailed information about your CPU architecture, cores, threads, and more. The lscpu command provides details such as architecture x86-64, number of cores, CPU model and vendor, clock speed. This information is helpful for system tuning, capacity planning, or troubleshooting performance issues. Go to the Google Colab link in the description to practice. The Python script below will run the lscpu command for you. Here's the script. Import subprocess. Running the command to display CPU information. Result equals subprocess.run. Capture output true, text true. Displaying the output in Colab, print result.stodout. Run this script in Colab, and you'll see detailed information about your CPU. This is an example of the output. Architecture x86-64, CPU op mode S32-bit, 64-bit. Byte order, Little Endian, CPU's 4 model name Intel R-Core Ti5-8250U CPU at 1.60 GHz. The output provides valuable details, including the number of cores and the processor model, to help you optimize your system performance. Try this out in Colab, and let's move on to the next command in our list.
Let's now learn how to check the available memory on your Linux system. Monitoring memory usage is crucial for performance optimization and troubleshooting. The Linux command we're using here is free-h. This command displays memory usage in a human-readable format, showing both used and available memory. Free shows the total, used, and available memory, including swap memory. -h formats the output in an easy-to-read way, such as displaying sizes in MB or GB instead of bytes. Go to the Google Colab link in the description and run the Python script to execute this command. Here's the script. Import subprocess results, subprocess.run, freeness h, capture output true, text. This is an example of the output. mem 6G, 4.3, 10G, 300 men 1.7Gs, 11G, swap AG 1G, 7G. Next, we'll learn how to display detailed system information. This command provides an overview of your system's hardware and operating system. The Linux command we're using is uname-a. It displays comprehensive information about your system. Uname shows system information, including the kernel version and OS name. -a displays all available details, such as the host name, kernel version, machine hardware, and operating system. Open the Google Colab link in the description and execute the Python script to run this command. Here's the script. Import subprocess result equals subprocess.run and capture output a true. Print result dusted out. This is an example of the output. Linux Ubuntu 5.5.56 generic x86-64 new Linux. Try this command in Colab, and let's move on to the next one in our list.
That's all for today. I hope you enjoyed learning these commands and practicing them using Python and Google Colab. Don't forget to check out Part 3 for even more essential Linux commands for administrators. Please like, share, and subscribe to support the channel and stay updated with the series. Thank you for watching, and I'll see you in the next class. Happy learning!